Welcome to the Swine Health Black Belt Podcast, the latest swine health research digested for you. My name's Dr. Clayton Johnson, and I'm your host for today's episode. Joining me on the podcast is Dr. Joel Sparks. Dr. Sparks is a practitioner like myself, and he's going to share with us today practitioner's perspective about whole genome sequencing for PRRS viruses specifically, and give us some case studies of how he's actually using that technology to help producers do a better job manage PRRS. Joel, welcome to the podcast. Thank you very much for being here. And why don't we kick it off with giving the audience a little bit of introduction, who you are and what you do.
Oh, hey, sure thing. Thanks for that, Clayton, and thank you for having me on today. So, background on myself, grew up in Southwest Michigan, undergraduate at Michigan State University. My passion for pigs took me out to Iowa State for veterinary school. And then 2015, joined on with AMVC and have been working based out of Indiana, but with farms in the surrounding states here, enjoying the practitioner side of life.
Very good. And in Indiana, now you moved there from Iowa. You don't have to deal with PRRS anymore, right? You moved away from Iowa and Pig Central, and Indiana's got to be PRRS free, I would think.
I wish I could say that's the case, but unfortunately it's not.
Yeah, understandable. You know, we had a wonderful podcast here a couple episodes ago, Joel, with Dr. Daniel Linhares and Giovanni Trevisan, and they talked about the nuts and bolts of whole genome sequencing for PRRS. I don't think we're going to get that technical, but in case the audience is interested in some background, check out that previous podcast with Daniel and Giovanni. We're going to pivot a little bit from that podcast and try to apply the science that they brought to us. You know, there's a diagnostic capability there, but you know the old rule with diagnostics, Joel, don't do the test unless you have a plan for the results either way. So let's just start there, Joel. As you think about whole genome sequencing for PRRS, how does it influence decisions you're going to make when it comes to PRRS management? How does it better help you answer questions that are important to the producers you're working with?
Yeah, absolutely. And I think I'll just maybe pause a little bit and preface that with biosecurity and husbandry, if I could put it in two words there, because if we can live without PRRS, that's far better than having to deal with it. So biosecurity, and then if we do get a disease, PRRS or something else, good husbandry, good care of the animal will help get us back to where we need to so much quicker than if it were the opposite. So, you know, I think I'd be remiss to, jump into a talk here about PRRS virus on the practitioner side and not emphasize the importance of biosecurity and good husbandry in this. So, but back to PRRS virus and molecular testing surrounding that. So if, for whatever reason, maybe surveillance or general diagnostics, we'll get some samples, send those off to the lab, and commonly would order like a PRRS PCR, right? And that's just to see if there's genetic material there or not. You get a positive, and like you said, you don't run a test unless you have a plan with it. So most cases we want to know more about that positive. And up to this point, we've been very common with doing ORF5 sequencing, and that basically PCR tells us, hey, yes, there's genetic material from PRRS virus there. ORF5 sequencing then tells us what the genetic code is for that small segment. But the thing with that is, ORF5, it's only about 600 nucleotides, 4% of the whole genome. A whole PRRS genome's around 15,100 base pairs. So, what we can do now with next generation sequencing is we can attempt to recover that whole genome, all of those 15,000 some nucleotides, and understand the code of the genetic virus better. So, within next generation sequencing, if we are able to recover the whole PRRS virus code, that's whole genome sequencing. If we run this next generation sequencing and we only get fragments of it, we still have information, but those are called contigs, and then we're able to work with those. And so what we've got, so say we've got that PCR positive, we order the sequencing on it, we get the information back. Now we have a bunch of letters in a different arrangement, and then we at least in my case, then I'll reach out to somebody in the diagnostic lab. You mentioned Dr. Giovanni Trevisan. He's been a huge help in this with me. I'll get this giant genome sequence and then say, hey, can you help me? He'll get that, put it into software program, and then what we have at this point is then we can compare it to another virus, whether that's a vaccine virus or another field virus that we have in our database, or maybe they have somewhere else. So that's what whole next generation sequencing is with PRRS virus. And then I do have a couple cases where this diagnostic approach has brought things to life a little better. But again, basically, when I'm dealing with a case and I get that PRRS virus positive, and I'm asking myself the question, do I sequence or not? And do I do next generation sequencing or not? I really ask myself, do I need better detail for now or possibly later to this case and where we might go?
Well, let's talk about your cases, Joel, and how are you applying this in the field? If you've got some examples on specific situations where you were able to get the whole genome and compare it to previous whole genome sequences, presumably from the same farm, how have you seen that be beneficial?
Yeah, so I do have one case where, and it's more vaccine virus related, but it's a case where a sow farm about this time of year, a year ago, got a call, and there were some mild clinical signs. It's kind of sounded like PRRS, wasn't real sure, but we were going to do the diagnostic workup and figure out what we had. So we did get some PCR positives, and as normal, we say, okay, well, let's run the ORF5 sequencing, and we did. And what we got back was that it was a 98.7 relatedness to a vaccine virus, but it was a vaccine virus that we had retired from using at the farm for about a year. And that just looked really odd. We thought, why would this show up? And it was 98.7 on ORF5, and the diagnostic lab will put a label of wild type at that. It's kind of arbitrary whether they say vaccine like or wild type like, but that's the label it got. So we attempted the next generation sequencing, and then in that it brought light to it, because when we got that information back, again, same case, that the next generation sequencing showed us that it was, on the whole, if you're looking at all the nucleotides, it was 95.1% similar to the vaccine that the sow farm was using. And that made more sense. Still some variance there. It wasn't 100%, it was 95.1, but it made a lot more sense than our original sample, our original result. And then that retired, I'll call it the retired vaccine that we had stopped using a year ago, on whole genome, it was still showing up, but there was only like an 88.4 similarity when looking at that. So again, it was just, now we're increasing the power of our microscope to analogously speak to that we can see better now. And in this, it did help us do some decision making as far as what are we going to do, where did this come from, and what are we going to do moving forward.
And I would assume it helps you a little bit from a prognosis standpoint, especially when we're dealing with diseases like PRRS that are no fun. Sometimes as any health professional, you just have to give bad news, right? And we don't have a silver bullet in the gun that's going to fix this. But the prognosis and how bad it's going to be is critically important. If it's a big producer, they may just need to know, how many pigs do I need to get to backfill this hole that's coming at me? But do you think that's potentially a longer-term value proposition with the whole genome sequencing as well, that as we better understand the differences in isolates that are out there, whether it's a vaccine virus or not, that we can help producers to maybe project what sort of impact we might see based on the whole genome sequence?
Yes, I do. Well said on your comments there. And I do see that as a future piece about it. Talking to Dr. J.Q. Zhang there at Iowa State, he recently shared at the Iowa State McKean Swine Disease Conference that, the nasty 174L1A, that PRRS strain that is a nasty strain, and the nasty 144L1C variant, two that have a bad reputation amongst producers across the nation. Those two nasty strains, they share a common 100 amino acid deletion when you look at their genome. So there's this commonality that these two virulent strains share. And I just think as we continue to build the next generation sequence database, and as we understand things like that better, then it will help us to be more predictive and help us to better control and eliminate things like PRRS virus in this case.
Excellent. Very applied, Joel. Great job using the tools that are out there and being on the cutting edge with applying those tools. I want to thank you, Joel, for coming on to the show today and sharing your thoughts with us and to our audience. Thank you for listening to the Swine Health Black Belt podcast. If you haven't checked out our website, please go check it out. You can see some of our older podcasts there. If you haven't heard the one on whole genome sequencing with Giovanni and Daniel from ISU, please check that one out. It's a great companion to this one with Dr. Sparks. And don't forget to subscribe to the podcast so that you won't miss out on any of our future episodes. Thank you very much for joining us. Thank you, Dr. Joel, for coming on. And to our audience, we will see you next week. Hey, everyone. We're always searching for the latest and greatest research to share each week. If you have a swine health-related research trial and would like to come on the show to talk about it with me and share it with our audience, feel free to send an email to healthblackbelt@swineit.com, and we would love to take a look at your research.